Okay, today I'm going to be testing if my supersonic ping pong cannon is really supersonic. Okay, so I wanted to explain this a little better because some people were confused about how this works. So what I do is I put a membrane on each side of it, one on this side, one on this side, and then I vacuum out the air inside the tube so there's no more air. So then once the air's out, the ping pong ball is sitting about right here. I pop this end. Now there's a great amount of pressure compared to the inside of the tube here. So on the inside of the tube there's very low pressure. On the outside there's very high pressure. And so the air rushes in and it makes the ping pong ball accelerate down the end. But what makes it be able to reach supersonic speeds is the fact that there's no air inside of here. If there were air inside of here, then the limit that the rushing in air can reach is about the speed of sound. It would be choked flow, it's called. But if there's no air inside of there, the limit is a different limit, and it's actually 2 over gamma minus 1, where gamma is the heat capacity ratio. And what that equates to is it can actually reach around 3 to 8 times the speed of sound. So this gas face coming in reaches around 3 to 8 times the speed of sound. That doesn't mean that the ping pong ball is moving that fast. It means that the air rushing in is moving that fast. Before we measure how fast it is, let's test it out on a can of soda. I've got my soda set up here, ready to film. Let's see what it does to a full can of soda. 3, 2, 1. Okay, so this is the damage to our soda can here. I still can't find the ping pong ball, I don't know where it went. So what I'm going to do is I'm going to shoot the cannon and I'm going to have a ruler so I can measure the length that the ping pong goes in one frame, and then I'll be able to calculate how fast the ping pong is actually coming out of the cannon. Okay, let's turn on our vacuum. Okay, 3, 2, 1. So in one frame, it looks like the ping pong ball goes around 9 inches. You can see the blur of the ping pong ball covers about 9-inch span of that ruler there in one frame. So that is around 229 meters per second, or around 512 miles per hour. Okay, so it turns out the ping pong ball is not supersonic when it exits my vacuum cannon. And the reason is because even though the gas is going into the cannon may be supersonic, but the ball has some mass and some inertia to it, and the gases have to speed up the ping pong ball, and it doesn't speed up fast enough by the time it exits the cannon. What I think I could do to make it even faster is to make the tube longer. Right now it's only a 6-foot tube, but I think if I make it longer, I could be able to get it to go faster because it has more time to speed up by the time it exits. Hey, thanks for watching another episode. If you're not subscribed yet, consider subscribing, and you can comment in the comment section with what you'd like to see me do next. Give me some good ideas there, and I'll see you next time.